Hello everyone, let's solve this problem. We have 3 to the power of x plus 3 to the power of x equal to 90. Sorry, we are dealing with 90. Okay, so what do we do? And the question given before us, we have log 5 to base 3 to be equal to 1.46. Therefore, we must get log 5 to base 3. And then we'll substitute 1.46. Now the question is, how do we pick out log 5 to base 3 from this problem? Okay, now take a step further. 3 to the power of x plus 3 to the power of x. This is going to be 2 multiplied by 3 to the power of x, and it's equal to 90. This means that we have 3 to the power of x. That's what it means. Now, why don't we divide by 2 and divide this by 2? This will cancel this, and then 3 to the power of x will be equal to 45, right? And then the next thing we do is to take the log of both sides. Take log of both sides. Okay, so when we take the log of both sides, then we shall have log of 3 to the power of x equal to log of 45. Now, there is a law that says powers can always go behind, so I'll have x log 3 equal to, now this log 45, since we are going to pick out 5, let's break 45 down to 9 times 5. Then if you take a step, you have x log 3, which will be equal to, according to the law of logarithm, if you have to multiply, then you're adding the logs. So we have log 9 plus log 5, right? Okay, so from here we need to eliminate log 3. So I will divide this by log 3, divide this by log 3, and then divide this by log 3, because I need to make x the subject. This and this can now cancel each other, so that x will be equal to log 9 over log 3 plus log 5 over log 3. And then from here, what do I do? Remember, 9 is the same thing as 3 squared. So x will be equal to log 3 to the power of 2 over log 3 plus log 5 over log 3. Now, if we continue from here, remember that powers can always go behind, right? So x will be equal to 2 log 3 over log 3 plus log 5 over log 3. From here now, log 3 can cancel log 3, and we have 2 over 1, which is the same as 2, meaning that x is equal to 2 plus log 5 over log 3. Now remember what we were looking for, right? We were told that log 5 to base 3 is 1.46, but from here we can point that out. Remember, if you have this log a over log b, now this is the same thing as log a to the base of b. Now that's the same principle I'm going to apply there now. So I have x to be equal to 2 plus log 5 over log 3 will be the same thing as log 5 to the base of 3. And from here we continue. x will now be equal to 2 plus log 5 to base 3 is given to us as 1.46. Okay, this is an approximated value. So that's from here, x will be equal to 2 plus 1.46 will give us 3.1, okay, 3.46 actually, right? So this is the value of x that should satisfy the given equation. But then let's impute this and see if we are right or wrong. The original equation is x, 3 to the power of x plus 3 to the power of x equals 90. Remember what I told you? I say this is the same thing as 2, multiplied by 3 to the power of x, and this is equal to 90. Now, if we put in the value of x, we'll have 2 into brackets. We have 3 to the power of 3.46 because x is this. Now, will this be equal to 90? Now, let's take a step. This will be 2 multiplied by 3 to the power of 3.46 will give us 44.75 approximately 0.75, and will this be equal to 90? Now let's multiply 44.75 by 2 and it gives us 89.5. And now can we say this is equal to 90? Remember, this is an approximated figure, so we can approximate this to give us 90. That is if you have to approximate it to the nearest whole number, right? So therefore, we can be correct when we say x is approximately 3.46. Thank you for watching.